Today we'll talk about SolidWorks plastics. So this is one of the design validation tool. So this gonna help us to simulate the plastic parts as well as the injection molds. So it also helps us to simulate how the resin flows through the cavity. So let's directly jump onto the SolidWorks plastics and we'll directly jump to the base. So I need to check the mold feasibility of this particular component. So with the plastic flow simulation, so for that I'll simply jump to the plastic tab, and over there I am gonna get all the tools. So there are set of procedures to follow. I'm gonna define the material here. With respect to material, uh, you can directly import all the flow characters and the mold temperature, flow temperature, and the flow rate, and even injection mold temperature, injection mold pressure. Each and everything will be automatically imported by just defining the material here. So once that is done, you need to define other parameters like boundary conditions as well as the domains. We do have the definition for virtual mold as well as the runner system and cooling system as well. So we have defined the cavity here, and in the boundary condition we can define the injection location. So at the back face I have defined the injection location, so the diameter doesn't matter here. And even do we have the options to deal with coolant inputs as well as the mold wall temperature and so on. So from the general tab we could able to define the flow and pack and warpage parameters. So right now I'm select only the ambient temperature as a reference, that is 30 degrees Celsius. And after that you need to mesh and run the study. With respect to that, we gonna get the results as in the form like this. So here I'm gonna deal with the flow results. The total fill time is 1.74 seconds. So according to the standards it should be less than 3, so that is okay for us. And the pressure at the end of the fill is 56. We could able to do this by just changing the material. And we have the cooling time, that is 14 seconds. So on an average it should be 15 seconds as per the standards. We are good to go with that also. And ease of fill, everywhere it is good, no issues with that. And the sink marks, there are no much sink marks. Dealing with the 8 traps, as you could see all the 8 traps has been located on the parting line. We could directly eliminate them. Okay, so now dealing with the pack results. So pack in the sense after the flow, once the flow is done, we're gonna pressurize extra resin to fill it up properly. The temperature of the end of the packaging is on an average 220, and the freezing temperature is also given, and the seconds is also given, and the residual stress at the post process. The results are available with respect to that also. The last thing is to dealing with the warpage. The total stress displacement is 1.3. as per the standard it is 2. We are good to go with that also. And the sink marks at the final stage of the warpage, it's good, only 0.3. And we could able to check the other results. So the warpage stage gonna help us to predict how the component gonna deform at the final stage during the shrinkage as well as the ejection. The last thing is the XY float. Here we're gonna get the mass participation. So at the package, on an average of 170 grams of mass is taken into account. So from this we could finalize our results are good to go with. So total fill time is 1.74, pressure at the end is 56, and the warpage is 1.3. So we are all set. From this we could conclude there is no defects with the plastics. We could directly take this one into account and we could proceed. That's all about plastics. Thank you.